Unit 6, Geometry. Properties of a parallelogram. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Properties of a rectangle. All properties of a parallelogram apply. All angles are right angles, and the diagonals are congruent. Properties of a rhombus. Opposite angles have equal measure, diagonals are perpendicular, and diagonals bisect opposite angles. Properties of a trapezoid. Bases are parallel, opposite sides are congruent, angles are congruent, and the diagonals are congruent. Properties of a square. Diagonals bisect and meet at 90 degrees. Diagonals bisect its angles. Opposite sides are equal length and parallel. All four sides are equal. The diagonals are equal. Perimeter is the length of four sides. Area equals length times width. Our first example. All my sides are congruent. I have diagonals that bisect my vertex angles. My diagonals are perpendicular. What am I? I am a rhombus. The second example. My legs are congruent, my base angles are congruent, my diagonals are congruent, and they bisect. What am I? An isosceles trapezoid. This is a chart explaining transversals and angles. A transversal is a line that cuts through a set of parallel lines. Parallel lines are a set of two or more lines that do not intersect ever. Vertical angles are opposite angles created by two transversals in a set of parallel lines. Corresponding angles are angles that correspond in the same location. One is on the left and top of the first. Line 2 is on top of the second parallel line. Angles, alternate interior angles, are angles on opposite sides of the transversal and inside the second parallel lines. Alternate interior angles are congruent. Alternate exterior angles. Angles on opposite sides of the transversal and outside of the two parallel lines. Alternate exterior angles are congruent. Consecutive interior angles or same side angles. Angles on the same side of the transversal and inside the two parallel lines. They are supplementary. Linear pairs. Supplementary to form a line. The midpoint formula is x1 plus x2 divided by 2 and x1 plus x2 over 2, and that equals a coordinate pair. So the example is prove that the quadrilateral with vertices at -1, 1, 1, 4, 7, 3, and 1, and 5, 0 is a parallelogram. So you use the midpoint formula to prove that the lines
the diagonals bisect each other.
The diagonals bisect each other. The slope formula is y2 minus y1 over x2 minus x1. And that's how you prove that parallel lines are parallel. Prove that the quadrilateral with vertices -3, 0, -2, 4, -7, -6, and -8, -2 is a parallelogram. And the slopes are equal, so it is a parallelogram. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. You prove that the sides are congruent with the distance formula. Prove that the quadrilateral with vertices -4, 1, 1, 2, 4, -4, and -1, 5 are a parallelogram. And the answers are the same, so it is a parallelogram. So you prove that the quadrilateral A, B, C, D at 1, -2, 13, 4, 6, 8, and -2, 4 is a trapezoid. And opposite sides are equal, so it is a trapezoid because it has one set of parallel sides and not two. So prove that a quadrilateral at -2, 3, -2, 6, 2, 7, and 1, 3 is a rhombus. And you use the distance formula to prove that it is a rhombus because all the sides are congruent. So to prove that this is a parallelogram using the midpoint formula, you make sure that the answers are equal, and it is a parallelogram because the diagonals bisect each other. Now that it is the end of this video, you should know that properties that make each quadrilateral unique, what a transversal is, vertical angles, corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. You should know what a linear pair is, how to apply a quadrilateral to its properties, the distance formula, the slope formula, the midpoint formula, and proof of parallelograms using coordinate geometry. Credit slide. Haley is the speaker, Marina is the cameraman, and Elisa is the paper slider.
Okay.